Welcome viewers, in this video we'll see the 2-bit synchronous binary up counter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic 2-bit synchronous binary up counter. So counter is a digital device that is made up of flip-flop. Flip-flop is the storage element. It will store 1 bit of data. N number of flip-flops are connected to form the counter. So it will perform the counting operation from 00 to n or n to 00. Up counter means that is starting from 0 to n, increasing order. Synchronous. Synchronous means all the flip-flop receive the clock pulse at the same time, so that the operation of the flip-flop is done simultaneously, so that it is synchronized. All the flip-flops are connected same clock pulse, so output is synchronized. Here 2-bit. 2-bit means 2 to the power 2. 4 possibilities are available. 0, 0, 0, 1, 1, 0, 1, 1. So this 2-bit synchronous binary up counter will give 4 different outputs. Now we'll see the detail. So in this counter, clock pulse is connected in parallel to clock input of both the flip-flops. Because of 2-bit we need 2 flip-flops. The clock pulse is connected parallel to both the flip-flop. That is called a synchronous. Asynchronous means clock pulse given to the first flip-flop. Output of second flip-flop is the clock pulse of the output of the first flip-flop connected to clock pulse of the second flip-flop. So that is asynchronous. Here clock pulse is connected to both the flip-flop. The output of flip-flop f of naught is connected to J1 and K1 input of the second flip-flop. Here output from the first flip-flop is connected as a input of the second flip-flop. Clock pulse is same, but output from first flip-flop connected to input of the second flip-flop. Right. Now we'll see the logic diagram. So we have 2 flip-flop available, f of 0, f of 1. JK type, JK flip-flop. What is the nature of the JK flip-flop? If both the inputs are 0, there is no change in the next state. If both the inputs J and K are 1, then the output will toggle. Output is 0 means it will toggle to 1, 1 means toggle to 0. Right? So see here, the first flip-flop, the high, logic high is given, 1 is given. J naught is 1, K naught also 1. J naught equal to K naught equal to 1. For the first flip-flop, both J and K input receive the high input. The second flip-flop, J1 and K1, input J1, K1 is nothing but Q0. Output of the first flip-flop is connected as a input of the second flip-flop. So that J1 equal to K1 equal to Q0. Output of first flip-flop is input of the second flip-flop. So the output is Q1 and Q0. MSB, this is LS. LSB, this is MSB. Right. So both the flip-flop receive same clock pulse. The flip-flop 1 input is high, logic high. Second flip-flop input is output of the first flip-flop, Q0. So based on that, we'll see the clock diagram. What is the output of this circuit? So the clock pulse is given, normally given, is called a positive edge triggered clock pulse. Whenever the clock pulse rises, so during, this is the positive edge clock pulse. This is the negative edge. If the inverted clock pulse is given, every negative edge, the state of the flip-flop will change. The clock pulse is directly connected means every positive edge, that is from 0 to 1. This is 1 to 0. 1 to 0 means negative edge. 0 to 1, low to high is called a positive edge. So this is the positive edge. Similarly, this is the positive edge. Second pulse, third pulse, fourth pulse. So the flip-flop will change of state will occur every positive edge triggered. This is pulse 1, 2, 3 and 4. Right. So we are using positive edge triggering. So this is nothing but positive edge. Connect changes from 0 to 1. So initially the 0, 0, Q0 also 0, Q1 also 0. Initially both the inputs are reset, both the outputs are reset, 0, 0. So that flip-flop 1 receive the clock pulse. The inputs are high here. So inputs are high, so the output, the flip-flop output will toggle. Toggle means changes from 0 to 1. During this positive edge of the clock pulse, because of high input, J0 and Q0 is 1. So this Q0 value will toggle. Initially it is 0, now toggle to 1. Until the next positive edge. Until the next positive edge, the output is 1. Toggle from 0 to 1. Then what is the input of this J1 and K1, that is 0. Initially Q0 is 0. So 0 is there. J1 also 0, Q1 also 0. There is no change. Both are 0, 0 means no change. Here both are 1. So the Q0 is toggle from 0 to 1. Here both are 0 during the first clock pulse, no change until the next positive edge triggering. Now the next pulse is available. When the next pulse is applied, what happen? Again this flip-flop will toggle, because always the input of first flip-flop is 1. So it will toggle from 1 to 0. Output is low. Now this 1 is applied. This one Q0 changes from 1. Now 1 is applied to the second flip-flop. If 1 is applied, mean what happen? Toggle. So this 0 will toggle to 1 until the next 0. Right? The same thing appears. Now the second flip-flop toggle from 0 to 1 because of this one. Earlier 0. Due to 0, 0. No change. Due to this 1, because this output is given as a input of the second flip-flop. So due to 1, the state changes from 0 to 1. Right. So this is until the next clock pulse. Right. So here we'll go to third clock pulse. This is the third clock pulse. When the third clock pulse is applied, again this flip-flop 1 will toggle from 0 to 1. Right. Now this 0 is applied. So due to 0, no change. 1 is maintained as it is until the next positive edge. When goes to the fourth positive edge, again this output toggles 1 to 0. Due to this 1, the output will toggle, the second flip-flop output will toggle from 1 to 0. Right. So these 4 flip-flops, 4 pulses are applied. Again the same process will repeat. See what is the output here? Here 0, 0, 0, 0, 1, 0, that is 1, 0, then 0, 1, 1, 1, again 0, 0. Otherwise 0, 0, 0, 1, starting from MSB to LSB, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0. So we got 2-bit, 4 possible outputs are available. I will explain again. This first flip-flop input is always high. So every clock pulse it will toggle 0 to 1, 1 to 0, 0 to 1, like that. Second flip-flop, the input is output of the first flip-flop is connected as input. So here 0, so no change. Here 1, so it is changed 0 to 1. Again 0, no change. 1 is maintained as it is. Here 1, this toggle from 1 to 0. Right? When 1 is there, it will toggle. When 0 is there, no change. Right? So that we are getting the pulse like that. Now the description is available. So what we discussed, the statements are given. Assume that the counter is initially in the binary 0 state. Both flip-flops are reset. When the positive edge of first clock pulse is applied, first flip-flop will toggle, because both the input J0 and K0 is 1, so that it is toggles. Whereas flip-flop 1 will remain 0, because J1 and K1 is 0. Initially we are made 0. After first clock pulse, Q0 become 1 and Q1 become 0. Right? This is the first clock pulse. When the leading edge of second clock pulse 2 occurs, flip-flop 1, that is 0 means 1, will toggle again. So Q0 will go low. Right? Every clock pulse, first flip-flop toggles. Since flip-flop 1 have high input, the previous output of the first flip-flop is high, so that high is applied. So J1 and K1 is high now at the triggering edge of the clock pulse. So the flip-flop will toggle. So Q1 goes to high. Now Q0 becomes 0, Q1 become 1. Now changed, right? Now we'll go to the third clock pulse. When the leading edge of C clock pulse 3 occurs, flip-flop again toggles. So because always it will toggle because both the inputs are 1. So again it become 1. And flip-flop 1 remain set because its J and K inputs are low. See, this low is there. Due to low input, there is no change. After the triggering edge, now it become 1 1. Earlier 0 1, now 1 1. Now we'll go to the fourth clock pulse. Finally, at the leading edge of the clock pulse 4, Q0 and Q1 goes low because they both have toggle condition. Both are inputs are 1. J1 and K1 inputs. So it becomes 0 0. Earlier 1 1, now 0 0. Right? So in this video we discussed 2-bit synchronous up counter. 2 bits, there are 4 possibilities: 0 0 0 1 1 0 1 1. Synchronous means clock pulse is given to both the flip-flop. Up counter means 0 to 1. So both the flip-flop receive same clock pulse. First flip-flop input is always high. So it will toggle. Every clock pulse it toggles. Second flip-flop input is from first flip-flop. When it is 0, when it receives 0 means no change. If it receives 1 means it will toggle from 0 to 1 or 1 to 0. That is called a synchronized up counter. So we discussed the logic diagram, then the timing diagram with the clock pulse, then we discuss the description also. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.